Hello everyone. Okay, so today we're going to be going through some examples of factorizing. These are five quadratics that I would like for you to try to factorize on your own. These are the ones that we're going to be going through throughout the video. So I would suggest that you first try to do them all on your own, and once you've attempted all of them, then you continue watching the video. Alright, let's start with this one. So the first step is to check that the coefficient there is 1. So we do have a 1 there, it's implicit. So we have 1x squared, we could rewrite it as 1x squared plus 2x plus 1. It's not necessary, I just want to stress that it has to be a 1 there before we can continue. Okay, so now we're looking for two numbers, a and b, such that a plus b is equal to 2 and a times b is equal to 1. So a and b must be factors of 1. And for this example, it's quite easy because 1 only has one factor, and that is 1. So we can say that a is equal to 1 and b is equal to 1. And we can double check that because a plus b then would be 1 plus 1, which is 2, so that one works. And a times b would be 1 times 1. Let me fix that there. And that's going to be 1, so that one works too. So 1 is our a and our b. And then how do we write that in our brackets? Well, we first put our brackets in, and we say x plus 1 and x plus 1. So we just rewrite it as with the factors a and b over there. Right, so how would we approach this one? Well, we again want a plus b to be equal to 4 and a times b to equal 3. So we would start by thinking, okay, what are the factors of 3? We can use 1, 3, because 1 times 3 is going to give us 3, and then we can test that. So 1 plus 3 is equal to 4, so that test passes, and 1 times 3 is equal to 3, so that test passes as well. And then to write it, put our brackets, we have x plus 3, x plus 1. And you can write it as the other way around as well, doesn't particularly matter, because it's multiplication, so it's commutative, so it's okay. The order doesn't matter. Alright, so how are we going to approach this one? Again, we want our a plus b to be equal to 5, and our a times b to be equal to 6. So let's try a few factors of 6. We can do 6 and 1, and if we say 6 plus 1, that's going to give us 7, so that doesn't work in that case. So immediately we can say 6 and 1 are not the ones that we're looking for. And vice versa, we can say 1 and 6, but that's going to just give us the same issue, so we're not even going to explore that part. Right, so now we think, what are the other factors of 6? Well, we could say 3 and 2, and then we can test that. 3 plus 2 gives us 5, so that test passes. And then, of course, because they're factors, 3 times 2 must be equal to 6, so that passes as well. So then we can write it as x plus 2 and x plus 3. Alright, so this one's going to be a little bit different, reason being because we have a negative here. So what we're going to be doing is we're going to be finding a plus b again, it's going to give us 2, but our a times b has to give us negative 3. That negative is very important. So what are the factors of 3? This is a very nice and easy one because 3 is a prime number, so it makes it a bit easier for us to choose. So we can say negative 3 and positive 1, because if we take those two together, we're going to get negative 3 times 1 gives us negative 3, so that one works. And if we say negative 3 plus 1, that's going to give us negative 2, so that doesn't work. So negative 3 and 1 doesn't exactly work. But in this case, we can swap the negative around. So what if we went with positive 3 and negative 1? Again, of course, if we multiply them together, we're going to get negative 3, so that case passes. But then if we say, if we add them together, we get 2, and that case passes now as well. So then here are our factors, 3 and negative 1. Right, so that's our first brackets. And now how would you add the negative 1 into brackets? It's quite simple. all you would do is you would say x minus 1. All right, here's the last example. So let us suppose that this is the problem. Again, we have 8 here, so we're going to say that a times b is going to give us 8, but we have a negative 6 here, so our a plus b must give us negative 6. Okay, so at this point you should realize that the sign of the coefficients is really important. Right, so let's try a few factors of 8. We have 8 and 1, and right off the bat we can see 8 plus 1 does not give us negative 6, so that doesn't work. And if we swap them around, it does the same thing, so we won't pursue that further. How about 4 and 2? If we said 4 plus 2, we would get 6. And that's not negative 6, so that doesn't exactly work. So what we're going to be doing is all we need to do is say negative 4 and negative 2. Because if you look at it, negative 4 times negative 2 will give us positive 8, so that works. And then if you look at negative 4 minus 2, that'll give us negative 6. So at this point, we have both of our test cases passed. So negative 4 and negative 2 are our solutions for this one. And the way that we would write it is we would just say x minus 4 times x minus 2. And if you would like to test whether your solution is correct, if you're kind of unsure, then there is actually a very nice shortcut method to test your solution. All you would need to do is you would check the inners and the outers. So negative 4x minus 2x, and that gives us negative 6x, and that's what we want over there. And then lastly, we would just check the outside, so negative 4 times negative 2, and that gives us 8, and that's what we want over there. So our solution is probably correct. So we can rest easily knowing that we're probably right here.